Hello and welcome with you guys in our Transit Autonomous System video series. Let me ask you something. Would you like to try building a small service provider autonomous system and to see how can service provider give a legacy network service to a customer, like what enterprise customers get? So let me introduce to you this little transit autonomous system in our lab, where you will learn how to use your routing and switching experience to build your core network, to build your access network, how to prepare and use both for delivery of different services like MPLS VPNs, layer 2 and layer 3, internet service delivery for in customer branches, customers HQ, how to test different special use cases with BGP to deliver main and backup connections for certain customer premises, internet backhauling, and applying policy-based routing. As a side note, we have built our lab using Cisco devices on EVNG network simulator, but later on we will start inducing other vendors like Juniper and others. As a first step, and before going deeper in our lab, we will discuss network connection types. So here we will start speaking about network connections. We are meaning here the physical connection types. So we have two types, point-to-point and point-to-multi-point. For a point-to-point network connection, when two interfaces of two devices are directly connected to each other, so we are calling this as a point-to-point connection. Both of these devices will be considered in the same collision and broadcast domain over this point-to-point connection. Both of these devices can have a point-to-point network implied between both of them only, just one. Each of these devices can reach to other networks, thus the other one knows how to reach to. Here we go. We have R1 and R2 directly connected with each other through this point-to-point connection between Ether 0/0 interface in each one. So let's have our test. In our lab and from R1 side, we need to find out the interface status. So we will type show IP interface brief. But here we are in the global configuration mode, so we will add do before our troubleshooting command. And without do, as you can see, the router didn't accept the command. Okay, now do show IP interface brief. We got Ether 0/0 stats is administratively down. This is our interface that we will use to configure. We repeat this action with R2. As you can see, Ether 0/0 is administratively down also. So now from R1 side, we'll start the configuration. Interface Ether 0/0 under the global configuration mode. Then no shutdown to operate the interface. You will get a notification message notifying you that the interface state has been changed to up. Let's try to show the interface state. It's up now. It has been changed from administratively down to up. Let's configure the IP address 172.29.25.1 255.255.255.252. For the duplex, we will force the duplex to be full, as these are VMs which may not negotiate for the right duplex. So we will repeat these steps again with R2. Interface Ether 0/0. No shut here, okay. IP address 172.29.25.2. The same mask. Duplex full. Let's move to R1. Look, you can find a duplex mismatch messages coming from R2. This is proof on what I have told you moments ago, that these VMs may not try to negotiate on Ethernet level for the right duplex. So here forcing is the best choice. Now we have configured the local and remote IP. So let's troubleshoot. Show IP interface brief from R1 and R2 side. Yes, everything is okay now. The IP and the interface state. Let's go to R1. Let's ping the local IP. Wow, we got successful ping, and now let's try to ping the remote one. Yes, we got a successful ping too. So, thanks for watching. Don't forget to subscribe our channel, like, and share our videos. See you again.